This video is about gray code to binary conversion for the solution. The program now has this routine to keep track of which bits are in the solution and which are not. It does so with this list called test list, which gets changed by the values in gray data at offset 4000. At 4000, one of the bits will be turned on, and then at 5000, one will be turned off. So this is how it keeps track now, but this addl instruction is in the loop and executed every time it goes around for the number of trials. So this adds to the time it takes to go around all the trials. In fact, it takes about 20% of the time to get the gray code search because of this additional instruction. This instruction can be taken away if we use the gray code. That is, if instead of doing this each time to remember what bits are in and which are not, it simply says, remember the value of I. That is the gray code value. So down here, when we found the best one, all we'd have to do is say, set the best trial to I. And we could take out this instruction altogether. Well, that would mean, though, that we have to take that I value that's in gray code and change it to binary. Well, that's what the routine over here does. First, it sets all the quantities to 0. Then it says that the best trial is less than or equal to 0. Go to EP, which is down here, go home. That means there are no bits on. Therefore, the trial says nothing is in the solution. That should never happen. Well, next it sets V equal to the best trials. And then it's going to go around a loop here for I of 0 to 20. It's never going to get to 20 because this value of V will become 0 at some time and there's no bits left in the list. Well, inside this loop it says set result bits of I to the value of V. Well, at the beginning that's the best trial. Then it takes the module of that with 2. Which means that it's either going to be 0 or 1. Then it divides our V by 2. So what it's doing is extracting every bit that is on from the value in best trials. That would be the gray code bit we're talking about. Next it says it wants to remember the most significant bit is set to I. Wants to remember which one it was. Then it says if V has become 0, we're going to go to EH. Well, what's going to happen is there's no longer any bits left on. It's finished. Alright, so eventually, if it keeps dividing it by 2, it's going to eventually go to 0. Well, then it comes down here and it sets U to that most significant bit that it found up here. Then it fills the 20 values at gray bits with 0. Then it sets the first gray bit plus U, alright, U was the most significant one, to 1. It's simply saying that when you go to the binary conversion, the first bit that it finds is going to be on. Well, that makes sense, because if it's off, it wouldn't even be there, would it? So that's the most significant bit, is always on, going to be on in the binary answer. Then it subtracts 1 from U. If it's less than 0, it goes to EK down here. It's finished, because there's U is knows how many of them there are, and if there are no more, then it's finished. So it sets gray bits of U to the result bit 1 ahead of U. That's the previous bit. Adds the current bit to it. Then does modulus to 2, so it's 0 or 1. This is how gray code works. it adds the two together and then does the modulus to 2, and that gives you the answer for binary. Well, we saw here it's going to go around here until there are no more in the list because u became 0, less than 0. So it goes to EK, and down here is the same routine that we saw in the regular program when it was taking the values in test list and getting the actual quantities for each of the items, except this time it's in the gray bits. And it goes around here and it sets j equal to the bits item, and then it's added its factor in. This is just like it did it before using the test list. Well, it called it best list at the time, because down here you'll see it was set to the best list. So this gets the answer the same way that did. But so the conversion is up here. And as I say, if you're actually writing a serious program that's going to do the search over millions and millions of times, you might want to take out this instruction and do it this other way. Well, this is the end of the video on gray code to binary conversion for the solution.